Inverter.
Hi, welcome to clickmeproject.com. In this video, we'll providing that complete demo and explanation about the project of a fault-tolerant scheduling system for computational grids under the domain of grid computing. Fault-tolerant scheduling is an important issue for computational grid system, as grids typically consist of strongly varying and geographically distributed resources. The main scheduling strategy of most fault-tolerant scheduling system depends on the response time and fault index when selecting a resource to execute a certain job. In this paper, a scheduling system is presented that depends on a new factor called scheduling indicator in selecting resources. This factor compromising of the response time and failure rate of grid resources. Whenever a grid scheduler has jobs to schedule on grid resources, it uses the scheduling indicator to generate the scheduling decisions. The main scheduling strategy of the system is to select resources that have the lowest tendency to fail. Extensive simulation experiments are conducted to quantify the performance of the proposed system. Experiments have shown that the proposed system can consider improved grid performance in terms of the throughput, unavailability, turnaround time, and fail tendency. Next, we're going to see the flow of this process. In this flow, we need to creating that grid environment. The grid environment contains the grid information server as well as the number of grid resources. After we collecting that grid resources, we need to creating the set of jobs. So the jobs only submitted by that users. So before that creating the gridlets, we need to creating that users. After creating the users, the job submission will be performed to that resources. Here the jobs are collected to that scheduler. The scheduler will monitoring that all resources and computing that expected time for each resources for a particular job. After getting this, we have to getting that minimum time, which one having that less failure rate. Now the job will be allocated to that particular resources. If the allocated list for all jobs will get ready, after that the transmission of jobs will performed. Now the job will be executed in that each resources which was allocated in particular resources. When we get the results, the status of the results will be checked whether it is fail or successive. If fail will be occurred means the fault rate will getting increased and the scheduler indicator will also getting decreased. Then we have to resubmitting the job to that another one resources for the further execution. Next, we're going to see the complete demo of this process. For this process, we need to run in the fault scheduling.java file. In the running window, we need to entering that number of resources. Here I have to creating 4 resources. So next I need to entering that number of users. So I have to creating that 4 users. Then number of jobs. I have fixing that each users having 3 jobs. Now the network will be initialized and the resource 0 MAPS rating will record. MAPS is the speed of each resources. So I have to fixing that first resource having that MAPS rating as, and that randomly I have to selecting that number of failures and the number of successive ratio for this job, and already our overall allocated jobs will be a 14. From this I have to computing that fault rate. Now that resource 0 will having that fault rate at 0.357. Next I need to entering that MAPS rating for resource 1. So here I have to put on 4600 for resource 1. In this resource having that 3 failure files and 9 successive jobs. This fault rate will be 0.25. After that I have to entering that resource 2. So the resource 2 having that 4400 MAPS rating. MAPS rating for this system will be 4450. So now that fault rate will be 0.5 for this resource 3. After this I have to creating that users 1 and the job 0. So I have to fixing the job length will be a 80,000 for first job, and I have to entering that 90,000 for second job and 1 lakh for third job. Now that user will created. Then I have to creating that user 2 with the ID of 24. So I have to creating the job with length of 20,000, 30,000 and 40,000. After computing this, I have to create the next user and I have to entering that 90,000, 99,000 and 98,000. Finally, I have to entering that last user's job length as 50,000, 60,000 and 70,000. After entering this, the scheduling operation will be performed. First, I have to getting that each gridlet and their length. The first gridlet length will be compared to all resource speed. I have to computing that transmission time, execution time and transferring time and overall scheduling indicator by using these three values. By computing this, I have to getting that first resource scheduling indicator will be 3171. As per the same mechanism, I have to computing a first job for all these resources. So it will showing that first job having all kind of resources. The same mechanism will be performed for all jobs. After computing that all jobs performance, I have to selecting that minimal and I have to selecting that minimal process resource. So this will showing that selection table. User 1 job 0 will be having that resource 0, resource 1, resource 2, resource 3 values like that. From this one we have to getting that minimal value from resource 0. So this J0 job will be allocated to resource 0 and resource 1. Now the selected resource for first job will be resource 0 and the selected resource for second job will be resource 2. From that same mechanism, I have to executing all the performance. After completing this, I have to updating that existing loads and proposed loads. Now the job will be submitted to all other resources and the processing status will be gathered, the resource ID and resourcing cost. From this one I have to computing that each resource and each jobs expected time and executed time and their status. Now all jobs will hitting successing radio, there is no failures. From this one I have to updating that success and failure ratio for each jobs. So that updated fault rate for each resources will be shown like that and that failure status for each jobs also showing. Next I have to showing that each resource fault rates. The graphs will showing that each job successing execution time in milliseconds and each resource having the timing in milliseconds for each jobs. Then finally we have to showing that success and failure ratio for each jobs. From this one we have to concluding that we have to implementing that less fault level scheduling mechanisms for the grid environment. Thanks for watching.